this module, we're going to be looking at more of the advanced features and some additional things that I like personally about Concord Pro and how we kind of used it, okay? Taking it, kicked it up the notch, as we would say, shifting gears. How many of you were here for the first session? Okay. What?
I didn't know it was kind of focused on Concord Pro. Sorry.
It is focused on Concord Pro, yeah. No, see you tomorrow, man. Come on. So some of the more advanced features, but also I hope that you've noticed the shifting of gears that we started with. And I can tell you that I'm going to finish off today with something that will, if you get this last point that I'm going to give you, is it will change your life. It will change how you see things in not just your career, but in life. All right. Anybody who has heard me speak before? How many of you have heard me before? No one. Wow. Shocked. Okay. So we're going to be looking at organizing your libraries. Okay, so in this module we're going to be looking at some special tools, the 4 stages of your PCB project, advanced Concord Pro features, templates and parameters, advanced Concord feature managed sheets, reusable blocks, and advanced card, some additional things. Anybody who has worked with doing a home improvement or anything else like that? Now, I just closed escrow on a house a week ago. We just moved on Sunday or Saturday, okay? So I'm still sore from that move, but I've already started doing home repairs. This is our first home, my wife and I. And anybody who's done home repairs can tell you, I can tell you how terrible of an experience it is when you're trying to do a project or to do put a nail in the wall with the back of a wrench. How many of you have done that? Okay, it's something where you're not using the right tool. Nothing is worse than using the wrong tool for the job. Okay, it gets hectic. And Altium's great business philosophy. I'm going to let you in on a little secret here. Altium's business philosophy is very simple. It's to provide the best tools to the PCB designers. And if you look at Altium and how it's structured, it's a toolbox. That's how we look at it. It is a toolbox for us to kind of tap into with various tools to use for different purposes. And we have those tools available to us, those tools, the wizards, the features, everything else. These are things that you should learn. These are things that you should become very familiar with. Why? Because they're tools in your toolbox, and learning them definitely helps you do your job much better. I told a story earlier about a guy who was doing length tuning using an Excel spreadsheet. When that is a feature, a tool in our toolbox, to be able to length tune based on just a few minutes, a few seconds, just plugging in a number and pushing go, and it automatically then length tunes. So there's two advanced, what I would say advanced, but understand when I say the word advanced, it doesn't mean they're complex. They're difficult. These are very simple tools, but there are additional things that I would definitely tie in. Something I want to talk to you about the component level is your component search panel. If you go into panels and up here on components, what this is going to do is it's going to search your local component library, your Concord library. This is an interface for you to be able to go in and do a component search. So what you have here is you're going to have your component categories that come up. Also up here, first off, you have your filter. These are the list of all the components, different things like that. But here, if you expand this out, you can actually have your parameters. Now, keep in mind that this is your search for your component, your library, your local Concord library. So as you can see there, you can do in the, let's say I'm searching on capacitors. I can then put in here the value I'm looking for, the case, the size, whatever. And it simply filters out then all the selection that you've done here. This has become a really valuable tool for us. Especially as we're in the component placement area. We want to be able to place components fast. This is where we do it. This is how we do this. So we simply get in here and start searching. So there you'll see a list and you'll say, oh, yep, that's the guy. Or you can just simply type in the part number if you know the part number here. If you right click on there, you can then say place that component onto the schematic directly from this component panel. So when I'm in component placement, I'm actually working with this panel open, searching components, what I'm needing, and then automatically just going ahead and putting them in there. All right? So it saves a lot of time. Now, the other panel here that I want to talk to you about is the manufacturer parts search panel. Now, how many of you are familiar with the Altium Content Vault? What was Altium Content Vault area? What's that? Okay, this taps into actually taps into Altium's Vault, Altium's library. Now Altium has a library they've already got set up of like 750,000 components or something like that. All components in there, verified, all that. And this is the search that they've done and the panel that ties into that. So if you go in here, manufacturer parts search, you'll then have the categories. And let's say you want to do passive components. Well, you can come over here and you can actually see here the same sort of setup with the filter. And with that filter, well, first off, this green bar down here is your component availability. Here is your components with models. So whenever we were creating components with automatically, and remember the automatic process, a lot of times what we'll do is we'll go into the manufacturing parts search area. We'll find components that have the models already, and we'll bring them in. This has become really interesting. I think what's going to happen here, and just out down the road here, what's going to happen is our local library is going to disappear. It really is. Because what's happening on this library is becoming a very, very good source for us, resource. It's become a big tool in our toolbox. And the reason, part of that is that these models are available that if you want to lay that component down on your board, you just directly do it from there. Now, a way that we've done this, if you really want to use your local library and you need your local parts, that's fine. So what we've done is we say, okay, we want to keep our library up to date with the components we're using, but we've actually integrated this into our design process now, that if someone comes over here, for example, and they say, oh, here's my component, it's not in our local library, there's a couple ways you can handle this. Number one is you can go ahead and use this component, put in a part request, and have then the librarian start building the component in your local library. You don't lose any design time that way. They've got a component down on the board, and they're working on the design. Or the other option is you can actually download this component and put it into your library automatically. Okay? So there's a couple ways you can handle that. So I would really highly recommend you tying into this resource. What question?
Yeah, this is why I'm here, because I use that. I also use that SAMSYS guy. There's actually a library component that you get for Altium that I want to look up bodies, and they'll make them, and you can download them.
Yeah.
Now, my biggest problem is it downloads it. It basically adds it to that project.
Okay.
It's not available to another project.
Okay.
How can I put those into my own centralized library? I'm confused, I think, on how to use libraries.
Yeah.
It's something I'm doing wrong,
Mm-hmm.
but I know that I get these parts, and it's like, well, I really want to use that same thing in this, like, and I've just copied it, files over, and then, and I've got multiple copies of the exact same parts, like 5 different records.
You're right.
And I know that's not the correct way to do it.
Yeah. So you actually download the component into your project and not your library? Is that what I'm saying? Yeah.
That's my confusion, because he does, that library loader then creates an AltiumLive directory. I
Mm-hmm.
believe it puts everything in there.
Okay.
Well, if I go to my local library, I don't think I see their parts.
Okay.
So then it ends up like dragging it into my project, and it creates another directory with that part name, And I don't,
Okay.
I'm not, this might
Interesting.
be out of this subject.
No, but I definitely want to see that process because maybe there's a disconnect somewhere along there.
That's what I'm wondering, if I'm just doing something wrong in my whole process,
Yeah.
or I'm looking in the wrong place.
Because I think Altium's powerful enough that you can, if you need to, you can actually create your own components. So I'm really kind of looking and saying having someone else create your components is becoming a thing of the past. I think if I mean.
I think I found that it was just easy.
Okay. Yeah. So we've actually seen it where we're using this manufacturer part search pretty extensively now. And we have some parameter information that we put into all our components. Are basically what we're calling our CPNs, our company part numbers that we're putting in, where our different business units. But other than that, we're pulling a lot of this right off of here. I mean, this has become a really great resource for us. So here's also then your price, your component pricing information, different things like that. All right, so in the same way, you can actually filter out your selections here that you're looking for, and once again, this is going to list out what your search is so far, and then these are the ones with available models. Understand if you're placing this component, you simply right-click and you say place. That's how simple it is. Now down here is where you say, would it be acquired? This is what you would put into a shopping cart. It's cute, but a shopping cart, and that's where you would acquire it, bring it down, basically downloading it. So then your components are placed into your design. So as we saw in our project module earlier, we saw that there was actually 4 stages of our project, and we saw that everything starts with stage 1 with that component library. That's probably the most important role in this entire PCB process is your librarian. They have a pretty important role. They have the ability, they have the task of setting everything on your library as being good and correct and starting your design. I have seen, there are endless stories that I could give you about small things in schematic symbols or PCB footprints that were wrong and that caused major problems in designs. Once again, the butterfly effect of hitting us. So the most important role in that entire PCB process is your component librarian. So the second stage is your schematic. Most of us know this. So your placement of your component here down into your PCB and into your output job files. That's your 4 stages. And there's actually design verifications for each one of these stages. Keep in mind, you have an input, you have an initial input here, which has an output. That output becomes the input, this output, input, so on, so on, so on, all the way down your line. You want to have a setup in your design process that will verify from the very beginning that your data is correct and you're working from good information. Don't assume anything. You know the meaning of assume, right? Makes an ass of you and me, right? When you make assumptions, that's where you're introducing risk into your design. And you have possible errors. So there's 3 different stages. Keep in mind there's 3 different stages here of design verification that you have for your library, your schematic, and your DRCs for your design, your PCB itself. Always verify those designs at each of these stages. Your components should not be released or allowed to be used in designs without being reviewed and verified, okay? Same thing, ERCs. How many of you are familiar with the ERCs? How many of you run ERCs? Everyone? Oh, only a few of you, okay. ERCs are all very important, guys. Learn to use those ERCs. DRCs, same thing. Then the other thing is always keep your design synced up. There's some special tools that Altium has provided that allow you to check your syncing with your design. Right here, for example, is your BOM. As we saw before, your parent and your child documents. But there's some special tools there that you can also use, okay, to make sure your design is synced up. Okay. So here, one of the big ones here is your library is going to constantly be changing. All right? It's just the facts of the process, okay? Your library will be changing. Sourcing information will be changing. Pricing will change on a daily basis. Improvements are being made. Different things will happen, okay? So when those things are pushed, when those things are done over here, if you're working on a schematic or in the middle of doing a schematic, one of the ways that you can verify that is by running your item manager. And that is actually double checks all your components. It takes your library and your schematic and it does a compare to say, how are we synced up? Are we synced up? Are all my components recent? Are all my components up to date? All these different things. What are my sources of my components? This tool, Item Manager, is probably one of the biggest tools I use. It is a major, major tool for us because we actually have to constantly keep checking our designs, making sure that the PCB design is correct and is in sync with the library. Because that library is a very dynamic thing. It's always changing. So keep that in mind. There's also, here is the syncing that happens. That is done through the syncing, pushing your schematic into your PCB. There's that sync. Whenever you do that, that should come back and say, okay, no changes. No changes, no differences between schematic PCB. Then also the syncing of that. So let's talk a little bit about templates and parameters. The great thing about Altium, or Concord Pro and Altium is that you can operate with parameters and templates. This is really nice because what happens is when you're setting up a project in Concord, it asks you the PCB number, PCBA number, for example. Those become what's called system parameters. And then those parameter information can be used throughout your design, simply identified by PCB number, PCBA number, rather than by this specific information. So this really becomes really nice because this then standardizes your design. So in a PCB, you're going to have 2 sides of this. Number one is you have your PCB. That is your bare board. That doesn't change. Your bare board's not going to change. That's going to keep the same copper, same everything on that design. So let's give you some parameters here. So in the PCB, you're going to have a PCB name, PCB part number, PCB revision. All right? So let's get some actual information here. So when we start looking at templates here, we can actually see what we're talking about. So here, you actually have bare PCB. Let's say we have a part number of 1, 2, 3, 4, 5, and we have a PCB revision of 1A. Very simple. Okay? So from that information right there, that's where you get your fabrication data. That's what creates that. That's your PCB side. On the other side, you then have the PCBA. So already we're seeing that we're going to need 2 numbers. All right, so that's your assembly. So you have variant 1, okay, which will then have, let's say, a variant name, a variant part number, and a variant revision. And let's say, just for information's sake, that's variant number 1, and that part number, and that revision level. Okay? So already we're starting now to develop the data that we're going to be using. This is data that we could tie into the PLM system to actually get from the PLM system when it's done. So I'm thinking, correct me if I'm wrong, Eugene, but we're still working on the variant information, right? Yeah. So. Yeah, exactly. So let's say you then, that's where you would then have variant data. But let's say you have 2 more variants. Now what would be a variant? Okay, let's talk about variants for a bit. Because a variant is when you'll say, I don't want to install a certain component, or I want to install an alternate component in a position. So let's say it's a value of a resistor, or you're changing your design. This has really become helpful for companies when they can build one PCB and create 12 different units. Okay? Yeah.
I have industrial version of my product.
Uh-huh.
Version of my product.
Right.
Relays are missing, and there's various features that
Right.
products don't need. So
Exactly. This becomes very helpful for companies because they can build one PCB and have multiple units they build from that one single PCB. Just by, and the choices are this, not installing something or having an alternate component. That's how Altium handles the variants, is based on those 2, okay? So keep that in mind. But this is why you need different information here. You may have different variant names, can have variant part numbers, or you can have variant revision levels also. Why? Because this revision could go through lots and lots of changes. This one won't change at all. So you have to kind of be prepared for that by saying, okay, I got to have my own variant revisions. And so from this, this should be familiar to us now, because what we saw was the 2 package sides of the package. You have a fabrication and assembly. This is your fabrication package. This is going to be your assembly package that's pushed over. All right. One document that's left out, the schematic. Now, this was a discussion we had over many meetings, was a schematic. Is it a PCB document or a PCBA? Huh? Okay. Okay. PCBA. Anybody say PCB? You want? Okay.
I mean, that's what you use to troubleshoot a board, right? If it's not working, so.
All right. But also keep in mind about child-parent documents, okay?
Your schematic changes, your PCBs don't.
Right. If you have a variant change, if you have a do not install component or an alternate component, then that changes your BOM. All right. So So what we did was we actually went ahead and we put the schematic in the data package, the data side, the PCBA side. So that's where we put that. Because the one thing that we wanted to make sure that we kept tied together was the BOM and the schematic. So that any changes on either one of those documents, which should be from the schematic, and not just the BOM, right, parent-child, is then they would stay synced up. If there was changes if you had the schematic over on the PCB side, that would then impact then the PCB. So what you need to start doing is, how you need to visualize this is that you can actually have changes on your assembly without ever changing your PCB. Okay? So your PCBA can have endless revisions. Your PCB may never change because you may just change values but use the same footprint. Now, what would drive then, one thing that we do is we want to make sure that any of our revisioning levels that we use, we stay synced up in this way. Let me explain. Is that, let's say we're up to revision 2, let's say we're up to 2A here, or 2C, and we have to, this is revision 1. It's never gone through any changes. PCB has never changed on us. Then we have to actually change something. We have to change copper. We have to make a change on the Gerbers that would impact the Gerbers. Then we bump everything up to the next revision level. That's our revisioning scheme plan that we use. Is that whenever this gets bumped, everything gets resynced. All right? That may or may not work for your situations, just keep it in mind. But we bump that major revision. We bump this what was back here, this 1A, okay? The PCB revision, the major value, which is your 1, and your minor, which is your A. We will bump the A for anything that does not impact the Gerbers. So that would be what? Documents, minor changes, things may be cosmetic, anything that doesn't require new Gerbers. As soon as then we need new Gerbers done, then the major is that 1 bumps up to a 2. Okay? That's just kind of the rules that we have set for ourselves. So I hope what you've noticed now throughout the day is that there's some rules that you need to set up to operate here. Okay?
So what would be 2B? Like not necessarily changing the copper, but say putting another mount hole on the board or something?
No, a mounting, okay, let's say you're putting a new mounting hole.
Not copper at all, but they just need to move the 1 hole up.
Okay, so if you move a hole, would that mean new Gerbers?
Yes.
Yes. So that means you would be bumping the major revision. Okay? So anything that any changes that you would make that would require, yep, I got to do new Gerbers. Change a hole or something like that, yep, new Gerbers.
Correct a typo in a
Let's say,
drawing or changing the solder mask color, which is a note fabrication drawing,
right,
then that would be the minor change.
that would be a minor change. Yeah.
In that case, so the variance won't get new part numbers, but we change the fab, the variance will get new rims because
Right.
on their farm now they're using a different
Yes. Right. The BOM would be updated. That's why you resync everything when you do a major revision on the PCB side. Everything gets resynced because now your BOM changes because you have to update the BOM for your new PCB, all that, your schematic and all this. Robert, how are you? Hey. So,
Just to finish that thought, one I think there's some revisions presented to the concept, like what's the revision of our Altium, which is design,
yeah.
in our repository. That design may have utilizing
Right.
Each of their own revisions.
Well, you're going to have a single number. You may have multiple revisions of that single number. So,
Yeah, I'm just looking at the design. I mean, there's our Altium sort of design. The design package is basically our managed, like we talked about our managed project.
yeah,
You know, that basically has the revision
yeah,
itself, separate from all the Hoffman as it generates.
right. So you got to divide up your project in this way, where you have your PCB side, PCBA side. Your PCBA can have multiple variants. We had up to, I think, the highest number of, we actually did a PCB design that had 15 variants on it. All right? And that,
Question on that.
yeah.
Where do you draw the line between like making another variant or making just a new board?
Well, I try to squeeze my boards as far as I can take them. If I can get another variant or another product out of it, that's great. That's less work. I don't need to go ahead and reset up an entire new project just for the PCB. I can run that variant off that PCB. Okay, so you can add as many variants as you want. So, but what's that?
Sorry, go ahead, Commissioner.
Yeah, the point is that the only changes you can make on that variant is what? Either not installing a component or doing an alternate component. As soon as you step out of that realm, now you're saying, okay, maybe I need to look at another PCB here. All right?
When you do the variants, is it in the same, you create a brand new copy of the schematic with the, do not populate on various things?
Well,
Or do you use the same schematic for everything and yet have a whole bunch of little...
we use the same schematic as everything was installed, and then in the variant, we're going to see this. When you set up your variant, then to see DNI or an alternate component. Yeah, and that then is that component will that schematic will be outputted. So here's your two packages: your fabrication, your assembly. The schematic will go into there. Each one of these items are supported by templates that are preset up in a Concord Pro to automatically used. All right. This is what makes it really convenient, guys. When I'm working with 50 designers, I don't want them going in and creating new templates for everything or schematic sheets or any of that. It's all standardized. It's all where every project is started with the same sheets. Everything is started with the same library. Everything is cookie cutter. You see? This may be a simple process when you got one or two designers in your company, but when your company grows, and I would hope that your companies do grow, you're going to see that this standardization is going to have to take place. You're going to have standard sheets. So what happens here is that each one of these templates, changing any templates can only be done by a system administrator, but parameters can still be used. So these are your type of parameters that you can use in your design. Here's an example. I'm going to go through this kind of quickly here. Here are some parameter information that you can use on your schematic sheet. So keep in mind, instead of using specific data, you're now pulling in parameter information rather than specific data. So that means if you go in here, for example, and you have your project name, which is one of the which is one of your parameters you can set up. When you originally set up your project, you say, okay, what's your project name? This is it. That's the information that's dropped in there. Every place that you put this label in your documents, then, that information is dropped in there. All right? That becomes really powerful, because now you don't have to make sure that okay, did I change this schematic name, this project name, or everything else? So, setting up your variants, you simply go in, and there's also then variant parameters that you can set up here. Based on so what information would go in here? It would be the variant name, variant part number, and variant revision. So here's your variant, your properties, and then your variant information here. That would be your parameter information. So same thing for PCB. Kind of give you a little hint here, a little trick. When we were working with SVN, that would be the version control folder number and the version control rev number. When we were working with SVN, we could actually pull those numbers in and use them as parameters on our schematic sheets and our PCB. So that's what this number is, right? Oops, wrong one. That's what this number is on our board at 3928. That was a revision control number, rev number that we dropped in there. That every build that we would do, automatically when we committed that to the repository, that number would then be updated on our PCB. So we could actually look at a board that we had in front of us and say at 3928, and we then could then go through our storage manager and know exactly what package that was. So it was a way of labeling. Now, what has happened? Any of you have seen the Git repository numbers? What are they? What's that? It's like what, 64 characters or something? It's crazy. We're still working on how we can bring that down to maybe like the first 4 characters or something. But it's not like this system was. But it was cool to be able to do that. So in the Draftsman template, there's 2 sheets to your Draftsman. There's a sheet template which then feeds into your fabrication template and your assembly template. Here are the parameters that are available for that sheet, those sheets. Keep in mind, you're going to get all these PowerPoints, and if anybody wants me to send them to you automatically, just let me know. I'll be glad to send these to you. But there's also a recording. I really appreciate our video guy today because I've really made it difficult for him. Because he was hoping I'd stay behind the podium, all right? And just do this, sort of thing like this, I've had too much coffee already today, so I gotta move, So he's kept up with me though, that's pretty good. So here's your parameter information. Once again, all this parameter information can be dropped into your templates. Every time your sheets then are changed, you simply go into one location, change your information on your parameter, and it's fed into all your other documents. It's great, okay? Draftsman sheets, your templates. Now also, this applies to your Excel output BOM templates. This is a little bit outside of the Altium world here. This is an Excel template, but you can actually set up your Excel columns to match up then with your columns in your BOM. It's always great. Also then your output job files. We have 2 output job files everybody uses, guys. 2 output job files. We have a fabrication output and we have a assembly output. Everybody uses that same output job files. They simply import it. They don't have to set these up every single time with the outputs, with the name and the revision and all that. What do? We do this little syntax down here of what parameter names that we want to apply. All right? And what we do here is we have the red is the parameter, the information joiner, and then the text information that you would have here. So this, for example, would be a variant name, PCBA number with a space, variant number plus -R, variant rev, _ output name. And that would actually output files like that would look like this, okay? So keep this in mind. You don't need to recreate. I had one of our designers come up and go, "It's taken me 3 hours to set up the output job file." And I go, "What?" Just input your file. Just input your output job file. It's in Concord Pro. This is where this output job file is saved. You simply import it and run, okay? And because you've set up your parameters in your design, that information then is automatically dropped in to the location for your file names. Makes it very, very simple. Okay, so here's an example of all the templates and files that the output templates that are used in Concord. The schematic, the PCB, the layer stacks are in there, your fab assembly templates, your output job files, your BOM, output Excel file. Your active BOM is in there. Also, Concord Pro handles very nicely your design preferences. Any of those setups can all be put and stored into Concord Pro. Yeah.
What about the rules? Design rules?
Yes.
Those also in there?
Yes. You can actually export your design rules, save those into your Concord Pro, and then people are actually loading up then those rules. Now, the one thing I will say about rules, though, try this. Try to take a high-speed rule set that you've set up for your high-speed design and pull it into a high-power board and see what happens. Okay? It's a lot of fun to watch all the errors that pop up, okay? The point is that you want to set up various design rules. And what you do is you actually should go in and set up an entire library of design rules for specific design types. That's what we ended up doing, was that we have our high speed, we have our high power, because we're not just digital high speed designers. We actually have a combination. We actually have very high power. We're dealing with high power designs. So we had to set up rule sets, and what we did was we actually went ahead and tied those rule sets into the standards that we were going to follow. Let's say your unit has to go through UL. Well, what we did was we took the standard of the UL that board would apply to, and we took those, we set up design rules, then we saved those off as saying, okay, these are UL qualified design rules. So we then were able to load up those design rule packages for what board we were doing. But what dictated that was the design rule based on the UL guidelines that we would have to go through. So we used the standards to kind of judge what rules we needed. So it was kind of a go-between there. So let's talk a little bit. Another great feature that I love about Concord Pro is the reusable designs. This is, I find that most designers, most double E's do not like reusable designs. They just don't like it for some reason. They like designing from the ground up, which is fine. But a lot of times we don't have the time. Remember the big concern that a lot of management has with PCB design is that time to market. That's a big thing they're pushing, time to market. We need to get this out faster, all right? So reusable blocks is going to become a major part of that. You'll see a lot of times in schematics this reusable sign, this recycle symbol I mean, this means that it's a reusable block, okay? So in this, you're able to save off a specific design into never mind this Altium Vault stuff up there, Concord Pro, and then take it back out and use it, okay? So here's an example of our library of reusable blocks. What we've done is we've saved off these designs, and we've saved them as reusable blocks or managed sheets. They're also called managed sheets in Altium. So here's your directory, your saved off reusable blocks, and then your schematic preview of that reusable block that you've used. So now, also here are what's called the child items that are used here, is that the components that are used in that reusable block. So now what we're doing is we're actually taking a snapshot of a schematic sheet. We're saving it off as a reusable block with components that are in the same library. And now we're going to start being able to reuse them. So all you do here is you simply say right click and you click that item. You say manage sheet. Give the reusable block a good name. And a sheet's going to come up like this, a brand new schematic sheet. Now in there, you can lay in your schematic. Now, a couple points here. I think the reason that we don't use reusable blocks very much is because it's very difficult at times knowing where to break your circuit and knowing what your inputs and your outputs are going to be and where you're going to break that. So having a solid circuitry like this, really what are we talking about when we're talking about circuitry, by the way? You have power, ground reference, and signals. That's really what we're talking about, right? Rather simple. So know where you're going to break your circuit. Like in here we have our power, our ground, and we have 3 signals coming in. This is a little control circuit for MOSFET, tricolor LED driven by MOSFETs. Very simple circuit. So also keep in mind that when you're doing a reusable block that you're going to have to put your ports of your power on your reusable block. The best way then is to connect up how many of you use connectors? Well, not the off-sheet connectors, but I'm having a brain moment here. What's it? A connector, what are hers says? What? Yeah, this down here is the, what is that? What? A signal harness. Thank you. My goodness. A signal harness. How many of you use your a signal harness? Don't? This is very, very helpful. In here you have a off-page port, for example, which goes to a single net. Here you're actually able to set up an off-page connection with multiple nets, however multiple nets you would like. And they go into that single harness, and they then go off the page from there. This is a really cool tool. I would highly recommend you learning this because that is really, really great. But along with then the reusable block, what we've done is we actually put information about the parts that we're using. See, this is the data sheet, the front sheet for the tricolor LEDs, some waveforms. Also, what we've done is we've actually put test points information on there. Any of the, what I would say, tribal knowledge that everybody has about this circuit, it all can go on this reusable block. It becomes a maintaining history of that design. That's what's great about this, is that all this tribal knowledge that everyone has about this circuit now can be documented. And it goes on here. Then every single time this schematic is used, it's laid down as a reusable block, it brings up this history as a part of this. So make sure to annotate this document. When it's brought in, it will be a read-only.
So is this the idea here then to have like a specific PCB layout thing that you can also have a block for? And that's where
there is a way around, yes, there is a way for that. But
that's what the idea here is, as opposed to just grabbing the circuit from some other schematic and copying and pasting.
yeah, I wouldn't copy and paste it from another schematic. First finding it, different things like that. Having different net names for your inputs, especially if you've maintained your input naming conventions, different things like that. It gets a little hairy when you're simply taking an old schematic and bringing it in. Keep in mind that because you have your components here, these will actually tell you if your components are out of date. So let's say this is a reusable block that you used 2 years ago, and you bring it back, and you check these components, and you find out, wait a minute, one of these components is now obsolete. That's the fear of pulling in, just making a copy of a schematic and dropping it in. There's no management of your component information of availability especially, okay? So keep that in mind that this sourcing right here, is when you use your components from your library, it also then manages your availability of whether that's a good choice or not. So these will come in and these components will be labeled as being, okay, this may not be your best choice here. Yeah?
Now, does that mean the designator follows the ground component when you go through a sheet?
I'm sorry?
Do the designators follow the components when you recycle a sheet?
The designators themselves are going to be what you set up on your schematic symbol, your default. Now, that's where you bring your annotation in, that you should annotate this. Make sure to annotate this page, because what you're going to do is this is going to bring in, let's say, your D1, your D2, and your so on. This is going to be a read-only, and we're going to talk about how then do we annotate this once we put it into the project. But make sure at this point when you're setting up your reusable blocks to annotate this, where it's at. So then you simply save it and release it to your server, release it to your Concord Pro. All right? So then you simply right-click, you place that reusable block, and as you can see here, this has brought in the single harness label, your power, and your ground. So now this project's, that new sheet that you just dropped on there is not going to show up until you compile the project. Keep that in mind. Okay? So now if you see it down here, it's now been added to your schematic list with all the information that you put on it. So let's say you want to make connections to an FPGA, for example. You want to use this sheet. So here you can actually insert your wire harness to this other sheet that you've got and simply then duplicate that signal harness that you've used and wire it in there like that, okay? You can make final connections to the top and so on. So there is another way, and you ask about PCB. I'm just going to get this. This is additional information, but this is outside of Concord Pro, though. Okay, these are reusable block snippets and design sheets. The snippets are local versions, locally saved. Okay, I think what you would do here is you would save these on a server. The snippets have a location on your server for the snippets. But this is not a part of Concord Pro, is it yet? No. I mean, we've been asking for it for a long time to be able to take a reusable block for a PCB design. That would be phenomenal. All right? And this is a way around that, is that you can actually then create a snippet of, let's say, that circuitry there. It's then locally saved on your system as a snippet. I find a lot of times I'll do this when I'm working with a design. I'll take a snippet of it and then save it off because I'm going to use it later or something like that, or create a reusable block out of it, something like that. That will simply add it. Now, you can also then do it a PCB snippet. Yeah?
Do you run into connectivity issues on PCB snippets if you were to duplicate the same circuit multiple times? So then you've got some resistor that's on the board and 4 different rooms, for example.
Yeah.
And you've got schematic, four schematics with basically the same part numbers if you have problems locating that.
The same designator, you mean?
Well, I presume when you bring it into the annotating.
What you need to do, yeah, when you bring the reusable block in, you'll need to do what's called a global or a world annotation of the design. That will then take your reusable blocks and annotate them into, because a lot of times what you'll end up doing is you may use that reusable block multiple times. So it's one of the techniques. If you have a reusable block, let's say it's a channel or a driver circuit of some kind, but it's 8 channels, for example, in an audio circuit. You simply lay that down. You don't have to lay it down 8 times. You simply, there's a syntax of when you give it a designator, it actually will copy it and repeat it 8 times. So there's a technique for that to not have to copy it each time. And then each channel then will be re-annotated according to what channel they're in. So multi-channel designing is really cool in Altium. So they made it pretty easy. So you can also then create a PCB snippet. Let's say in this circuitry here, I wanted to go ahead and copy this. Now, what this is going to do is I'm going to copy and I'm going to paste it off to the side. What I do is I copy what I'm looking for, and then I copy and paste it. It may need some cleanup, all right, because you're going to copy some stuff that you may not want, all right. So here then would be if you right click then on that circuitry, you say create a snippet from the selected objects, and that goes then into your printed circuit board snippets. Now what I usually do is if I'm creating a schematic snippet, I'll go, and I've already done the PCB side, I'll go ahead and save both of them. So I'll actually have how I looked at the design.
And how do you link them up later? You just
This is a,
PCB snippet, you then push the change into your schematic?
yeah. So what we do is like, okay, so let's say you wanted to creating a, so you'll see here that we now have a new PCB snippet, a 1.1V8 out circuit, and the schematic that attaches to that, for example. So if you go into your panels and into your snippets, that will open your folder. And then from there, you can say, place this snippet. And from there, directly from your panels, your snippet folder, and you can go ahead and place it from there. So that's what that. Important best practice is to create both the schematic and the PCB. Okay, so that's just. You can also do this with tire schematic sheets. This is your design sheets. Like I said, these are on your local system. So what we've done is we've actually taken that and put it up on our server so everyone has access to it, and we actually have an entire folder then of PCB snippets. So, because what we want to do is we want to be able to, remember, time to market, that's kind of being driven into us right now, time to market. If we've gone through a high power circuit, for example, and it's gone through UL, we take a snippet of that and we save it off, because then that tells us how we designed it, and we pull that snippet in the next time that we use that circuit, because it's already gone through UL approval, and we know that if we're going to be able to use that design again, we simply lay down that PCB layout as we did it originally the first time it got through UL, and we're done. We get through UL for most, like 99.5% of our projects that we send through UL get first time. So we just slam dunk them through there, okay? So working with binary files. This is probably one of the more the advanced features that I really enjoy. Let me check something here. This is probably one of the more advanced features that I really like. Yes? Oh yeah, please.
So when we spoke about design snippets and then you place the schematic snippet, you place the PCB snippet. The reason why I'm pointing this out is because it's one who will probably ask for a question. It's back to your question, how do you link them together? A lot of customers, they would end up doing a design update to a transfer to PCB. That is actually not a good practice in my opinion. I would rather do a component link, which you can access in the PCB document. Project component links.
Okay.
Match the schematic instance with the PCB before you do a design transfer.
Right.
Okay.
So component link.
Yeah, I understand that.
Very good. So one of the other areas that one of the more advanced features of Concord Pro that I really like is binary files. When you got 50 designers, all different levels, what we found was that we needed to provide training. And what we were able to do with that was that we were actually able to set up an entire library here of research resources, of documents, videos, recordings, training modules, anything that we found that was very interesting. There's some Mr. Roberts material in there. Sorry, sir. But this is very simple. What you do is you simply go in, you set up an item. What we did was we actually created an entire research library in here. There's thousands and thousands of documents in here. SOPs, procedures, processes, videos, all that. It's all uploaded into this area. And this has become very, very popular for us. All you do is you simply create the item and then you simply upload it. It's that simple, okay? And there's a lot of material in there. So that is also a great resource that I can give people to go when they're first starting to understand what our procedures are, processes, learning material, all that. So between that area and probably the Altium resource area, we got most designers covered, okay? Yeah. Yeah.
But if there's a library, putting in there like, okay, we've got those, there'll be like documentation that's quite common.
Yeah.
Like, suddenly it's like, oh, you've selected this part. Here's a link, is there a way, like, put a link in here saying, hey,
Yeah.
here's this part, go read these articles.
Yeah, remember, in your parameter information in that component, you can put anything you want. You can put links, you can put hyperlinks into different other areas. So we actually can link data sheets to those components, any of those parameter areas in the component itself.
Is that something in revision?
I think it does. I think, yeah, you're changing the parameter so it would change the revision level, but that's not a big deal.
Yeah, it's not a big deal. It's just, I guess, at the end of the day, when you've got your design, you're doing that final check, first of all.
Yeah.
Maybe there's something like that.
Yeah. I have something I'd like to throw out here. How do you guys handle your mechanical parts on your boards? Let's say you have a PCB and you've got a TO220 package you're laying down, and it requires some RTV, maybe an insulator, and a heat sink put onto it. How do you guys handle those mechanical parts that would go on your board?
Step models, right?
Okay.
You get a step file and you place it in the component library.
Okay.
We've had it used, everything on the layout.
Right. Yeah. Yeah. Because you're not changing your footprint. If you put the insulator on, the insulator for that TO220 package is still, the footprint's still going to be the same. Okay? So what we've done is we've actually created an entire library of mechanical components: screws, heat sinks, washers, all these different things. And what we've done is we've actually created an entire schematic symbol and PCB symbol for those mechanical parts. And you think, well, how do you do that? The one rule that you have to follow is that your schematic symbol has to match your footprint, right? That's a pin-to-pin thing. So what we've done is we've actually gone in, we've created a schematic symbol with, let's say, a picture of a screw. That's our symbol. We then, our footprint is our 3D model. It's just a 3D model. Then on our schematic, we actually have then a sheet on the very first page which will set up all the mechanical components on that sheet. So when we then push that schematic into our PCB, the 3D models for screws, washers, heat sinks, everything else we need for that PCB is added to the project. Also, when you export your BOM into the PLM integration, those components then are also added to your BOM as a part of the PCB project. But they're all on your schematic as a symbol of a screw, and here is then the information, parametric information for that screw. So we actually set up, and then because the symbol, there's no pins, what's the rule? Schematic symbol matches your footprint. We just simply have a 3D model that's pushed in. And it's a pretty cool method of doing it. But we'll have all the components on that board as a part of that. So I started out today by talking to you about the 2020 Corvette. How many of you were there for that? Okay. Thank you for staying with me for the day, all right? But I talked about how in the 2020 Corvette, with this 6.2 liter V8, this 500 horsepower, 470 pounds of torque, you go from 0 to 60 in 3 seconds, shifting through 8 gears, and that's a lot of power. That's a lot of power. And I can tell you, working with Altium, that you have a lot of power behind you when you're sitting down and doing your PCB design. A lot of power. And you're going to go from 0 to 60 in 3 seconds. But what if we never shifted out of our first gear? What if we never made it to second, third, and the other 8 gears? And we're still working the old ways and doing the old things the old school way or blah, blah, blah. Most of all, I'm going to talk to you something about outside of PCB design now. I'm going to talk to you about, I really like this university day. It's one of my favorite parts of AltiumLive. Because you guys are the serious ones. You took the extra day away from your companies, which probably most of you are like, yes, please. Right? But you came here because you want to learn. You want to shift your gears. You want to shift from first gear. If you're in a gear, you want to shift into your next gear. You want all the power that this machine can give you. You want everything that Altium can give you. You're not satisfied with just being in first gear. I need to get to second gear. I need to get to third gear. I've been in Altium for like 20 years now. Back when it was a little company called Protel. How many of you remember the Protel days? Yeah. All right? And I can tell you that Altium is never satisfied with what they have. Okay? Get used to it. You're never going to have the situation with Altium where they sit back and they go, you know what, we're done. We've developed everything we can develop. We're done and we're finished with this now. They are going to be constantly developing and redeveloping the machine that they've given to us. They are producing our 2020 Corvette. They're building for us our 2020 Corvette. And it's going to be our responsibility as designers to get in there and start shifting gears. That's up to you. Everything that you're going to be hearing today, this week, from some of the best keynotes in the world, from the best speakers in the world, is that you need to start shifting gears. Don't be just satisfied with first gear going 5-10 miles per hour down the road. Your industry is not going to let you do that. You're going to be the ones who are left behind when you don't realize the power that you've got with your tool. And a lot of this, I hope you're going to change, is your attitude, the attitude that you have regarding PCB design. And looking at something bigger. I talk a lot about to a lot of designers. And one thing I talk to them about is not the tool particularly, but what is their purpose? What is their direction? Where do they see themselves in 5, 10 years? Look, I'm an older guy in this industry. I'm a senior. Okay? You got some younger people coming up doing some amazing things with this thing. They've already shifted into 4th and 5th and 6th gear. They understand the power that they've got at their hands. For us, we need to shift gears. We need to constantly keep pushing, and a lot of that's going to deal with how we view things. So here we are. You've gone through Altium University Day. But where do you go from here? Now what? Thanks for the info. See you later. Bye-bye. All right? The old folks from SNL would remember. Bye-bye. Yeah? Bye-bye. But how do we strive for excellence after this is all over? It's easy to do things here. It really is. We're among friends. We're among our colleagues and everything else. But how do you get to the next level and shift gears when you're in your company, in your cubicle, struggling with the issues that we all face? That's what this is about. And if you get anything else from anything I've said today, get this. Get the next 5, 10 minutes and understand your next steps from where you go from here. Every one of us operates in 4 circles in our lives. 4 circles. That very first circle is called your comfort zone. This is where everything is safe, you feel safe, you're in control, you know everything is within your little window, your little area of influence. This is your comfort zone. And this is where a lot of people operate. They don't ask for anything more. They don't ask to do anything more. Just let me go in, collect my 8 hours, and come out. And, they just live in that comfort zone. And outside of that comfort zone is what is called the fear zone. This is where they're pushed outside of their comfort zone. And immediately what they do is they go into their fear zone. This is where you have a lack of confidence, you're prone to failure, you find excuses, you're affected by other people's opinions a lot. A majority of people will operate in one of these 2 zones. But not you. Not you. Because I know many of you. You've been here before. You've been in Altium. You understand what this is about. This is not about Altium. This is about you as a designer. And you've already kicked out of this comfort zone. You've already been kicked out of there. You've gone through your fear zone. And you're now working on other things. You've gone beyond that. There's another zone outside of this. It's called your learning zone. That's where a lot of you are right now. That's why you're here today. Okay? You were not satisfied with your comfort zone or your fear zone. You wanted something more. You wanted to rise to the challenges. You want to deal with changes in the problem. You want to acquire new skills. You want to extend your comfort zone. You're in that learning mode right now. And what I would challenge you with is this: always stay there. The fear zone and the comfort zone is still waiting there. It's waiting for you. Come on back. Hey, come on back, relax. You don't have to pressure yourself. Don't do anything beyond. And notice something about this. To go from your comfort zone into the learning zone, you've got to go through the fear zone. You've got to go through the fear zone. And it happens to all of us. This is not a judgmental thing. It happens to all of us. Keep moving forward. That's the point. Whatever zone you're in. But even beyond the learning zone, there's still another one. There's called the growth zone. This is where you begin to find purpose. You begin to live dreams. This is where you set new goals. You conquer new objectives. You are the designers. You are the designers that will design the great things that are coming up in our business that we have decided to devote our lives to. You are. You're developing now some of the great technologies that will impact our world. Yes, you. But only if you decide to live out here on the edge, where the minority lives. That's where the minorities work, right out there, the learning in the growth zone. If you're going to be satisfied with your comfort zone or your fear zone, forget it. You're going to be left behind. This industry will take no prisoners. It will leave you behind in the dust, and you will not realize that you're full potential. I believe you have the potential to be great designers. You are great designers. But the thing is, you've got to keep moving forward. Keep moving forward. You have a great purpose, a phenomenal purpose, and you're going to realize and you're going to see that purpose this week. This is only the beginning, and as I told you earlier, we're just warming up here. There's going to be a by Friday evening, 48 hours from now, you're going to have so much stuff pushed into you that it would amaze you. But only if you make a mental decision today to move from your comfort zone, through your fear zone, into the learning and growth zone. Take this as a challenge. This is your challenge for this week. You're away from your jobs, away from that stress, away from that pressure. Concentrate on you as a designer. Know where you're at and continually keep moving forward. Keep moving forward. I believe there's an attitude today in engineering is that you can't make mistakes. It's okay to make mistakes. Some of the great designers and some of the great scientists of our age made most mistakes ever. But they kept moving forward. And that would be the challenge I would give to you. Keep moving forward, folks. Don't be satisfied with your fear or your comfort zone. And if you're in first gear in your 2020 Corvette, it's time to shift gears. It's time to move up to the next level. Thank you very much. I appreciate your attention and your time today. It's been great. Thank you.